Yes. Hi friends. Welcome to the next gen chemistry class. Today we are going to discuss the Graham's law of diffusion. The Graham's law of diffusion. Graham's law of diffusion. So first of all we should know what is diffusion. Yes. What is diffusion? The definition is intermixing of gases. Intermixing of two or more gases against to the gravitational forces to form homogeneous mixture is called as diffusion. I repeat, intermixing of gases against to the gravitational forces to form homogeneous mixture is called as diffusion. If you take that, for example, a cylinder, from one side gas X, let us take the CO2 gas, and from another side any other gas like SO2 gas are released. These two gas molecules, they move randomly irrespective of gravitational forces, and they mix with each other and they form homogeneous mixture. That intermixing of gases is called as diffusion. That is the diffusion definition. Then the rate of diffusion. Rate of diffusion. S. You know that the rate per unit time is called rate. You may define as the rate the per unit. So what is the rate of diffusion? S. The diffused volume per unit time is called as the rate of diffusion. The diffused volume of a gas per unit time. The diffused volume of a gas per unit time is called as rate of diffusion. Therefore, the rate of diffusion generally denoted by R, the rate of diffusion is equal to diffused volume by diffused time. What is V? V is diffused volume. Diffused volume. What is T? Diffused time. Diffused time. Please don't confuse. T is the diffusing time, but T is not indicates the temperature. Sometimes the students may confuse the T. Instead of T, if it is denoted by capital T, it indicates temperature. Here the small t that indicates time, diffused time. Therefore, we completed two definitions. What is diffusion? The intermixing of gases irrespective of gravitational forces to form homogeneous mixture is called as diffusion. And what is rate of diffusion? The rate of diffusion may be defined as the volume of gas that diffuses per unit time is called as the rate of diffusion. Therefore, rate of diffusion is equal the volume diffused volume of a gas by the diffused time V by T. So, what will be the units of the rate of diffusion? The units of rate of diffusion is equal volume by temperature. You know the volume units are either cc's or milliliters or liters or decimeters, like that, by time units. Time, it may be second, that means cc's per second or liter per second, like that. That is the units of diffusion. Units of rate of diffusion. That is the diffusion and the rate of diffusion. Rate of diffusion is equal to V by T. The diffused volume by the diffused temperature. Yes. That is about the Graham's law, not Graham's law, diffusion and the rate of diffusion. Then coming to the Graham's law. Yes, coming to the Graham's law. What is Graham's law? A scientist named Graham, he studied about the rate of diffusion of gases and their relation with the density. A scientist named Graham, he studied the relation between the rate of diffusion of a gas and its density. And he found a relation. And he gave a definition as per his observations. That is, he stated a law that is called Graham's diffusion law. What is the Graham diffusion law? The rate of diffusion of a gas is inversely proportional to its density at a constant temperature and pressure. The rate of diffusion of gas is inversely proportional to the square root of density of that gas. That is the relation between the rate of diffusion and the density of the gas at a given temperature pressure. That relation that proposed by the Graham. So what is the state the Graham's law of diffusion? The Graham's law of diffusion is the rate of diffusion of a gas at a constant temperature and pressure is inversely proportional to the square root of its density. So rate of diffusion is proportional to 1 by root D. Therefore, Therefore, compare the rates of two gases and their densities. For example, the rate of diffusion of a gas is R1. Its density is D1. Then R1 proportional to 1 by root D1. Under the same conditions of temperature and pressure, the rate of diffusion of a gas is R2 and its density is D2. Then, according to Graham's law, R2 proportional to 1 by root D2. Therefore, if you compare the rate of diffusion of first gas to second gas, then R1 by R2 is equal root of D2 by D1, because R1 is inversely related to square root of D and R2 is inversely related to square root of D2. Therefore, R1 by R2 is equal root of D2 by D1. It is the first relation. If you know the density of rate of diffusion of two gases are known and the density of the one gas is known, we can calculate the density of other gases. So what is the application or what is the use of this equation? We can calculate the density of a gas by comparing its rate of diffusions, by the comparison of their rate of diffusions. So R1 by R2 is equal to root of D2 by D1. It is the first form of Graham's law. Then come to the second form of the Graham's law. We know that density is mass by volume. are the molecular weight by the density is the mass by volume. So in the case of density, density is directly proportional to molecular weight if you take 1 mole of gas. Therefore, density, because density is directly proportional to the molecular weight, in this equation, we may take molecular weight instead of density. Because density is directly proportional to its molecular weight, because density is mass by volume. For 1 mole of a given 1 mole of a gas, for 1 mole of gas, the mass that must be equal to its molecular weight. Therefore, density is equal to molecular weight by volume. Therefore, the density is directly proportional to molecular weight. Therefore, because the density is directly proportional to the molecular weight, we may define that the rate of diffusion of a gas is inversely proportional to square root of its molecular weight. So, the rate of diffusion of a gas is inversely proportional to square root of its density. Or the second form of the Graham's law, the rate of diffusion of a gas is inversely proportional to square root of its molecular weight. Therefore, instead of density, if we take the molecular weight, then R1 by R2 is equal root of D2 by D1. Because the density is directly proportional to the molecular weight, we may take, instead of D2 by D1, you may take M2 by M1. Therefore, we can calculate the molecular weight of unknown gas by comparing its rate of diffusion with a known gas. For example, molecular weight of one gas is known. We can calculate the molecular weight of another gas. If the rate of diffusions of two gases are known, we can calculate the rate of diffusion through an experiment. Therefore, the second form of Graham's law, the rate of diffusion of a gas under the constant temperature and pressure is inversely proportional to square root of its molecular weight. And when the rate of diffusions and molecular weights of two gases are compared, that R1 by R2 is equal to root of M2 by M1. Then, coming to the third relation, the molecular weight is nothing but 2 into vapor density. So, molecular weight of any gas is equal to 2 into vapor density. So, therefore, it may be taken that the molecular weight may be directly proportional to the vapor density. So, instead of molecular weight, you may take the vapor density. Therefore, the rate of diffusion is directly proportional to square root of its vapor density. That means the Graham's law can be stated in these three ways. Or otherwise, if we compare the vapor densities of two gases, then R1 by R2 is equal root of M2 by M1. M2 by M1. The molecular weight is directly proportional to the vapor density. Therefore, R2 by R1, R1 by R2 is equal vapor density of the second gas by vapor density of the first gas. Therefore, we can define the Graham's law in three ways. At a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to square root of its density, that R proportional to 1 by root D. That is equal, if you compare the rates of diffusion of two gases, then R1 by R2 is equal D2 by D1, because R1, D1 are inversely related, R2 and D2 are inversely related. So R1 and D1 inversely related. Here R1 D1, because those are inversely related, R1 by R2 is equal D2 by D1. Yes. Coming to the second form, because the density is equal to molecular weight by gram molar volume, the density is molecular weight by gram molar volume. Therefore, density is directly proportional to molecular weight. Because density is directly proportional to the molecular weight, instead of density, you may take the molecular weight. Therefore, the rate of diffusion of a gas is directly proportional to square root of its molecular weight. Therefore, Graham's law can be stated in another way. The rate of diffusion of a gas is inversely proportional to square root of its molecular weight. R1 by R2 is equal to root M2 by M1. That means the rate of diffusion and its molecular weight is inversely related. R1, M1 inversely related. Similarly, R2, M2 are inversely related. Then, coming to the vapor density, molecular weight is equal to 2 into vapor density. So, twice to the vapor density is equal to molecular weight for any gas. Therefore, molecular weight is 2 into vapor density. That means molecular weight is directly proportional to vapor density. Because vapor density is directly proportional to molecular weight, instead of molecular weight, you may take vapor density. Therefore, we can state the Graham's law in the third way. The rate of diffusion of a gas is inversely proportional to square root of its vapor density. So, R proportional to 1 by root Vd, and when the rates of diffusion of two gases and their vapor densities are compared, then R1 by R2 is equal to root of Vd2 by Vd1. These are the three basic formula. As coming to the other formula, here what is the relation between the rate of diffusion and diffusion? In the case of Graham's law, please remember, at a constant temperature and pressure, the rate of diffusion is inversely proportional to square root of its density. At a constant temperature and pressure. If the pressure is not constant, if only the temperature is constant, then what will happen? The rate of diffusion is directly proportional to the pressure of the gas. Friends, imagine, it is general thinking, a common thinking. If the pressure of gas is more, its the rate of diffusion is also more. If the pressure of gas is less, its rate of diffusion is also less. For example, if you take one cylinder, it is filled with a gas at 1 atmosphere pressure. Where another vessel is say, take another vessel. In this one, fill the vessel with the same gas with 3 atmospheres pressure. If the valve is open, from which the gas diffuses more. Here the pressure is 1 atmosphere. The gas is filled in a vessel with 1 atmosphere pressure. In another vessel, the gas filled with the 3 atmosphere pressure. If the valve is open in these two vessels, then in which the diffusion of gas will be more? Because the pressure is less, the less amount of gas will be diffused. Here the pressure is of the gas more, it will diffuse more. That means the rate of diffusion is directly proportional to its pressure. The rate of diffusion is directly proportional to the pressure. Therefore, we can define the Graham's law. The rate of diffusion of a same gas is equal to P1 by P2. If the same gas is taken at two different pressures, the same gas, for example, hydrogen gas is taken in a vessel at 1 atmosphere pressure. The same hydrogen gas is taken in another vessel at 4 atmosphere pressure. If the same gas is taken at different pressures, then the ratio of the rate of diffusion R1 by R2 is called P1 by P2. If two different gases are taken at two different pressures, if two different gases are taken at different pressures, because two gases pressures are different, R1 is by R2 is equal to P1 by P2. Because these are two different gases, because so R proportional to P and R proportional to 1 by root M. So based on these two different gases whose molecular weights are M1 and M2 are taken at two different pressures P1 and P2. Therefore, then the rate of diffusion R1 by R2 is equal P1 by P2 into root M2 by M1. Friends, the rate of diffusion is directly proportional to the pressure of the gas, and the rate of diffusion is inversely proportional to square root of M. If two different gases are taken, two different gas means they have two different types of molecular weights. Two different gases are taken at two different pressures. Then R1 by R2 is equal P1 by P2 into root M2 by M1. R1 is directly proportional to P1. R1 is inversely proportional to root M1. R2 is directly proportional to P1. R2 is inversely proportional to square root of its molecular weight M2. It is another important one, that is the fourth relation. Then compare the rate of diffusion versus temperature. Yes. Yes. Rate of diffusion versus temperature. Here so remember these three. R1 by R2 is equal to root of D2 by D1. R1 by R2 is equal to root of M2 by M1. R1 by R2 is equal to root of UDT by V1. R1 by R2 is equal to P1 by P2. R1 by R2 is equal to P1 by P2 into root M2 by M1. Yes. Coming to the next formula. Yes. Compare the relation between the rate of diffusion versus temperature. The rate of diffusion of a gas is directly proportional to square root of its absolute temperature. Friends, how we got this relation? This relation is derived from the RMS velocity. RMS velocity of a gas is equal to 3RT by M, root 3RT by M, RMS velocity, where for a particular gas its molecular weight is constant, 3 is constant, R is constant. Therefore, the RMS velocity is directly proportional to square root of its absolute temperature. Here, the RMS velocity of gas, if the RMS velocity of gas is more, the rate of diffusion is also more. General thing. If the velocity of gas molecule is more, that can diffuse more rapidly. Therefore, the C is nothing but rate of diffusion. Therefore, instead of RMS velocity, we may take rate of diffusion. Therefore, the rate of diffusion is directly proportional to square root of its temperature. Therefore, R proportional to root T at constant pressure. Therefore, R1 by R2 is equal to root of T1 by T2. It is another form. At a constant temperature, the rate of diffusion of a gas is directly proportional to square root of its absolute temperature. Or, if the rate of diffusion of a gas is given at a temperature, we can calculate its rate of diffusion at some other temperature. So R1 by R2 is equal to root of T1 by T2. By this, if the rate of diffusion of a gas is known at a given temperature T1, we can calculate its rate of diffusion at some other temperature T2. Yes, that is the fourth form. The next one. If two different gases are taken at two different temperatures. If two different gases are taken at two different temperatures. So, two different gases. The molecular weight of one gas is M1. The molecular weight of another gas is M2. The first gas is taken at T1 degrees Kelvin. The second gas is taken at T2 degrees Kelvin. And the rate of diffusion of first gas is R1 and the rate of diffusion of second gas is R2. So two different gases are taken at two different temperatures. Then how can we compare the rate of diffusion of the two gases? Then we know that R1 by R2 is equal root of T1 by T2 as per the above one. And you know that R1 by R2 is equal root of M2 by M1. R1 by R2 is equal to root of M2 by M1. Therefore, that is root of M2 by M1. Therefore, two different gases are taken at two different temperatures. Thereby, R1 by R2 is equal to root of T1 by T2 into root of M2 by M1. For example, a methane gas and helium gas. So, the methane gas, for example, taken at 27 degrees centigrade, its rate of diffusion will be, for example, something 0.4 meters per second. Calculate the rate of diffusion of some other gas, sulfur dioxide, at some other temperature, 127 degrees centigrade. Therefore, if two different gases are taken at two different temperatures, R1 by R2 is equal to root of T1 by T2 into root of M2 by M1. If two different gases are taken at two different pressures, then R1 by R2 is equal to P1 by P2 into root of M2 by M1. Here P by 1, P2, not under root. Here T1 by T2, it is under root. This is fifth form of the Graham's law. Then coming to the sixth form, if two different gases are taken at two different pressures and two different temperatures. Friends, in the first case, we compare the rate of diffusion of two gases at same temperature and pressure. At the same temperature and pressure, R1 by R2 is equal to M2 by M1. In the second one, the same gas is taken at two different pressures. Then R1 by R2 is equal to P1 by P2. If two different gases are taken at two different pressures, R1 by R2 is equal to P1 by P2 into root M2 by M1. Here, two different gases are taken at two different temperatures. Then R1 by R2 is equal to root of T1 by T2 into root of M2 by M1. The last case, if the two different gases are taken at different pressures and different temperatures, then the first gas molecular weight is M1. It is taken at a temperature T1 and a pressure P1. Let us take that its rate of diffusion is R1. The other gas whose molecule is M2 taken at P2 pressure and T2 temperature. Let's take that its rate of diffusion is R2. Then you can write the relation easily. R1 by R2 is equal. You know that R1 by R2 is equal P1 by P2. R1 by R2 is equal to P1 by P2. Therefore, P1 by P2. Yes. Then temperature R1 by R3 is equal to root of T1 by T2. So into root of T1 by T2. And these are different gases. In the case of different gases, R1 by R3 is equal to root of M2 by M1. Therefore, because these are different gases, M2 by M1. So, two different gases are taken at two different temperatures and two different pressures. Then, the comparison is R1 by R3 is equal to P1 by P2 into root of T1 by T2 into M2 by M1. Now, how many relations we got? So far we got relation 1, R1 by R3 is equal to D2 by D1. Relation 2, R1 by R3 is equal to root of M2 by M1. Third one, R1 by R3 is equal to P1 by P2. Fourth one, if different gases are taken at different pressures, R1 by R3 is equal to P1 by P2 into M2 by M1. Fifth one, the relation between the rate of diffusion and the observed temperature. R1 by R3 is equal to T1 by T2. If two different gases are taken at two different temperatures, then R1 by R3 is equal to root of T1 by T2 into root of M2 by M1. Seventh one, if two different gases are taken at two different pressures and two different temperatures, then R1 by R3 is equal to P1 by P2 into root T1 by T2 into root M2 by M1. That's all. That is all about the Graham's law and the possible formulae. Yes, friends, the concept is more important. Before go to the exercises, clearly understand the concept. What is diffusion? What is the rate of diffusion? What is the relation between the rate of diffusion and density? The relation between the rate of diffusion and molecular weight, and the relation between the rate of diffusion and vapor density, and the rate of diffusion between the relation between the rate of diffusion and pressure. Two different gases are taken at two different pressures. Then the comparison. If two different gases are taken at two different temperatures, if two different gases are taken at two different pressures and two different temperatures, there are 7 formulae. The total Graham's law depends on only on the 7 formulae. Please start the exercises. Either in stage 1 or stage 2 or an advanced level. All the problems that come under any one of these formulae. Without this, there is no Graham's law. Other than this, there is no other Graham's law. That's all. That is the theoretical background and the formula part. So, start the exercises. Try to complete all the questions, problems given in stage 1, stage 2 and at advanced level. If you got any problem, then let's discuss about the problem on tomorrow. Thank you.